what I can get is some kind of accumulated round-off error. And what should all these percentages add up to?
1.
1.0, and all these should add up to 100%, right? I'll put that way down at the bottom. These should add up to 100%, and this should add up to a 1.0. Well, if I keep rounding like this, and rounding, you know what can easily happen? I can get my sum to be 0.99. Or I can add them all up because I keep rounding, it might add up to 1.01. And I just recommend, if you can put that in a presentation, you might get a heckler who in the audience is like, hey, that's not adding up to 100%, that's adding up to 101%. So when we round these, we can always go back and tweak something if it's in the middle, just to make it look appropriate, all right? Is everyone okay with this? Absolutely, that's great. We could write like this, 5%. I think I'll do integers in my presentation. So when I'm going to write 5, and I'm going to put percent. Now, what's this next one? Anybody get it? 2%? All right. Hey, can you give me a few of those values off the decimal point? I'll write them down.
0.02473.
Just so people can see what she did. She got this decimal, and she's going to call that 2%. Cool. Now, when it comes to rounding, I agree with her. What was after that 2? Stare at that. What was it, 4? So if it's after the 2, it's a 0, 1, 2, 3, 4, we'll round down to 2. But if it's like a 5, 6, 7, 8, 9, I could estimate it rounded up to a what? 3? But I do want to say this. There's nothing wrong with this if I'm just estimating. That 4 is kind of in the middle, isn't it? So it wouldn't be wrong, as I estimate, if I rounded this thing to 3%. Okay, if I want to. Because I'm just making this in my presentation. You wanted to somehow give what? Some number, and you're like, the more values I put down, I think it's going to confuse my audience. I'm like, listen, the people who responded never was like 2 or 3%, right? Hey, this is going to be the same as that. All right, what's this one?
0.07232.
Ooh, 7%. This one? 15? 15%? And what's this last 3,093? 65%. And everyone, would you take a second? I think I'm going to present it like that tomorrow to my audience. Can we make sure these add up to 100%? And if they don't freak out. Go, that's expected. It happens sometimes. I'll go back and tweak one, and I might tweak that guy. Because he's kind of, see this? That's a 4. I can make that 3% if I have to. What does this add up to?
99.
99.
Ah, this is adding up to 99% right now. So when I'm putting my sad face, what went wrong? We expect this. No, really, we go, that can happen. I was rounding these. That's what can happen. So I go back in, I'm like, well, this one was, when Tia read that to me, I was like, 0.0247. There's nothing wrong with me just rounding that to 3% for my presentation. And I love that. So hey, it's good right now? That look good? You can do it like this. You could write this way. Some people like to do this. They prefer decimals without the percentage symbol. 0.65. You know, of all the things we do in this class, this is one of the most important things actually. Because this is what sometimes gets students, they get all mixed up. They're like, oh, I gotta write it like this or write it like this. If you want to be more accurate, that's totally fine. But I'll explain to him if you want to go to 3 decimal places. Absolutely. Everyone good? Right. Hey, so now we're going to 2.2. 2.2. What's this one titled again? Organizing. Quantitative. So I want to make one of these funny little, again. Me and I were talking about this. She didn't know the name of this. It's called a histogram, right? And when to organize quantitative data, similar to that bar graph, this is called a histogram. Histograms are used to organize quantitative data. So first step we're going to do is you and I are going to construct a histogram. All right, where's the data? Well, today I decided I want to use data that everyone in this class can see. And even if you don't have your textbook today, you're like, I can go back tonight and I can go look at this data. So I'm gonna use table from the book. This is in 2.2. Table 8, I was kind of bored by that. Number of arrivals at Wendy's, blah, that's kind of lame. No interest. I want something with, you know, with these decimals, because those can confuse some students. So I'm going to go to page 91, and I'm going to use table number 17. So if you're sitting there right now and you're like, I don't have my textbook, it's in a car that's buried in snow from the blizzard. You know, I want you. Well, I'm taking the table from page 91. It's got a lot of values there. We're going to construct a histogram from that. My goodness, how many values are in here? 1, 2, 3, 4, 5, 5, 10, 15, 20, 25, 30. There are 40 values in this table. Okay? And I don't have to write them on the board, you know, to write all these values, because I'm sure you can go look at these at home. A lot of you have your textbook out and you see these. Looking through the table, I wanted you to scan it. What's the lowest number about? What do you see the lowest number as? Just scan over it, like, oh, how small did they get?
3.3.
I'm hearing like 3.3, okay? 3.2, how high did it get? How high did it get? 11.7, oh, there's a 12.0? So when we get numbers like around 3-ish, going up to like 12-ish. All right, and you go, well, what is this? And when they said this was the 5-year rate of return. 5-year rate of return. What were these, mutual funds or something? Yeah, these were 5-year rate of return of some mutual funds. Some were at 3%, some got up to 12%. I know the one I want. I want that one that was getting 12%, right? Rate of return on my money, my investment. But some are down at 3%. Okay. So here they are all listed. So this is 5-year rate of return of these investments. We're going to construct a histogram from all these. All right. So when this is at, I want you to pay attention to the directions. You just asked me a good question about like rounding, right? Well, in these problems where you construct a histogram in the textbook, it'll be specified what should be your class width, all right, and your lower class limit. So I'm going to write this down. With the first class, I'm going to write having a lower class limit of 3 and a class width of 2. I'll read it to you again. Having a lower class limit of 3 and a class width of 2, I'll put a comma, and when I want you to construct a histogram from that data. That represents all that data.
So you mean like 3, 5, 7, that's
I
all?
love it. You know what I mean? So we'll go through this, because we're looking at here. What do these words mean? Limit, lower class, 3 and 2. So when we get this thing set up, all right, very good. What's the word over here, T again? Every time?
Frequency.
Frequency. So I'm going to put frequency here. You better, when we're still going to do this count thing, we count, oh, there's 6 of these, there's 8 of these. But down here, I'm going to make tick marks. I'm going to make some tick marks. You go, well, that's the origin, huh? Well, welcome to statistics. What did we say the lowest numbers around in that table?
3.
That's why when I asked this question, I'm like, I'm going to ask you to do a low class limit like 3. There's nothing in the 1s or 2s. So what do I do? Do I have to go 0 and then 1 and 2? No. Beauty of statistics. And when you start right here, you can just do a little squiggle. Just do a little squiggle off that thing. And I can put my lower tick mark, first tick mark at the number, what's that? 3. So on your test even, when you see this question asked, with the lower class limit of 5, right? Do a little squiggle and your first tick mark would be at what? 5. Does that make sense? Cool. Now, there's going to be more tick marks. And so how far do I spread these apart? That's that worth class width. So if the class width is 2, what do y'all think I should make this next number?
5.
5. Add 2 to it, right? So I'll put a 5. How about here? 7. 9. You know what's neat? I'm not even looking at the table. I could go too far. There's nothing wrong with that. There's nothing wrong with going too far. I didn't hear anything about anything in the 15s. The only thing is, will I have any rectangles here? No, that's what it'll indicate. So there's nothing wrong with going too far, but I had to make sure I did that lower class limit. So to see how this is appropriate, let's say I'm talking about values of homes. There's not many homes worth $3. But maybe like you're like, okay, I'm gonna start my histogram at 100,000, right? And I go $100,000 and I go by like 20,000 each time or something like that. Does that make sense? Yeah? All right, cool. So now when this is the only tedious part, oh, we're kind of, go ahead.
I don't understand what is the class weight number.
Oh, so are you okay with the lower class limit?
Yes.
Good, so we put that number here. For class width, when they provide that number for you, I want you to add that to this.
So you mean just only 3 plus 2 and equal 5?
That's right. And then you continually add 2. And then what we're going to do, it's going to be real easy, we're going to go to this table. You and I are going to count, it's kind of tedious though. We're going to count how many numbers are between this 3 and this number in the table. All right? And let's say there's 15 of them. All right, and I'm going to go up 15 notches. Does that make sense?
Yeah.
Cool. Now here, I got to be very, very careful in how I explain this. The number 5.0, if that's in a table, that's where students get confused. Do I put 5.0 in this rectangle, or do I put 5.0 in this rectangle because it's right on the line, right? That one, 5.0 would go in this section. So what I'm talking about, see right here? I'm actually going to count how many numbers are between 3 and 4.99 in that table. I'm going to count. We're counting how many numbers are between a 3 and a 4.99 in that table. Whatever that integer is, that's how high I'm going to build my rectangle. Okay? Now, it's tedious though. I have to go in here. There's software that can organize this stuff. Excel could do this. And the calculator could do it. But what we'll do is, it doesn't take that long. But let's go into this table. Can you help me count? I'm going to cheat though. I'm going to look on the next page at the answer. Can you count how many numbers are between a 3 and a 4.99 in that table? There's a lot.
29.
Is it 29? Someone getting that? 29 numbers between those? I'll look over here on that next page. Yep. So when I gotta go 29 high here. Now when I don't feel like making 29 tick marks, do you? So what would be appropriate? I could go by what, 5s? Yeah, I'm gonna do that. How about we'll go 5, 10, 15, 20, 25, 30, and there were 29 numbers between a 3 and a 4.99 in that table when we counted them. And sometimes when you count them, have you done this before? You gotta like use tick marks and you slash, right? It's a little tedious though, isn't it? I have to admit. So we go through there, but there are 29 of these. I'm gonna stop about right there. You know me, I like to put this at the top. Unless you're one of these who like to write the number really big, that's okay too. There are 29 of these rate of returns for 5 years that was between 3 and 5. These were actually in percentages, 3 and 5%. Oh, the other thing is I'm writing this, shouldn't I label this down here? So you go, what was this? This was a 5-year rate of return. They were in percentages, so I'll put that in parentheses. 3%, 5%, 9%. But it's quantitative. Is that okay with? Hey, everyone understand how we figured out this number? Even if you don't have your textbook right now? We actually went in the table. It was a little tedious, and we had to what? Count all the numbers that were between 3 and 4.99. Now, what do I do here? I have to go back in there and count how many numbers are between a 5 and 6.99. Okay. How many do you get?
5?
Is it 5? All right. Anybody else get 5? Now, what's different about the histogram in comparison to the bar graph? They touch. Look at this, everyone. This didn't happen in the qualitative data when we did the bar graph. You put these side by side. So you remember that? Histograms, these are like, whoop, right against each other. Awesome. Now remember I said there was only 40? What's 29 plus 5 already? 34. How many data do I have left? So I got to figure out where the 6 values are in this rest of this stuff. How many numbers are between 7 and 9? Not many, are there? For,
One.
I should say between 7 and 8.99. How many are
That's
there?
one, right?
Just one?
Yeah.
Alright. Just one high, huh? How many between 9 and 8 and 10.99?
9 and 11 is 4, right?
4?
Yeah.
Anyone else get 4? Taking them
One.
off? Alright, 4? Just counting right? And lastly, when there were none this high, but how many were between 11 and 13? Just one? Or there's more than one? I see 11.7 and 12. Are there 3 of them?
Yes,
29, 5s, 34, 35, 39, 42. There are 2 too many. Because we should only have 40, right?
There should be two between 9 and 11.
I love it. So we go back, we go, everyone, this is a great check. We're like, here, a sad face. Hey, what's wrong? Because you and I know that this plus this plus this plus this plus this should add up to what? 42. And we're like, what's going on? We go back, we look, and I'm hearing it. They're saying actually between 9 and 10.99, there were only how many? 2 of them. And now it works out perfectly. We catch that. And it happens, you know why? It's kind of tedious counting these numbers or time. When I was going in there, and you're like, well, and you make the little, you're like, all right, one of those, 2 of these, 3 of these. You can use the software for this, but I'll be honest, by the time you did this, you would have that stuff entered in there anyway. So, I mean, it's nice to use this. It's nice to use Excel to do this stuff. Yes, absolutely. You're doing this in a presentation in front of a large crowd, or you're going to do this for a report, you're definitely going to use Microsoft Excel.